First of all, introduction. The increasing popularity of automobiles globally has significantly boosted tire manufacturing. Over the last decade, China alone saw tire production rise from 776 to 816 millions, while Europe experienced an increase of 30 million tires in 2019. 3 billion tires were produced worldwide, leading to a growing issue of waste tires, projected to reach 1.2 billion tons annually by the 2030s. End-of-life tires (ELT) can be reposed of civil engineering or as fossil fuel replacement, with high recovery rates in regions like the US, Europe, China, and India. The tire life cycle involves production, transportation, use, and ELT stage, each contributing to environmental pollution, including nitrogen dioxide, benzene and polylights, aromatic hydrocarbons. Regulation like the Europe Directive and China's industrial standards aim to mitigate these impacts. Life cycle assessment (LCA) has been used since the 1990s to evaluate the environmental impacts of tires, but consistency in methodology remains a challenge. This study systematically reviews LCA application in the tires industry to understand and improve sustainability performance, presenting findings and future research opportunities. Next, goal and scope. First, study aims of literature. The literature reviews 8 primary study aims focusing on the entire life cycle of tires, end-of-life tires (ELT), design comparisons, secondary material application, and new impacts. Some study examine tires treatment process and new generation white-based tires (NGWBT). ELT studies analyze recovery methods, design comparison, secondary material application, new impacts, treatment process evaluations, and NGWBT benefits. Some study may overlook transportation stage in their life cycle assessment. Second, system boundary. The life cycle of a tire starts with raw material like rubber, textile, steel, and chemicals, processed into components, assembled into tires, transported to manufacturers, and reused for up to 20 years. Most study focus on the end-of-life phase, comparing environmental impacts of treatment method and exploring the benefits of changing end-of-life materials. Last but not least, functional unit. The functional unit (FU) is used in life cycle assessment (LCA) studies to measure inputs and outputs. However, there's no consensus on the appropriate FU, complicating comparisons. FUs are categorized into distance-based, mass-based, number-based, and others. Their methods can lead to biased interpretation if quality and function areas considered The lack of agreements limits LCA result usefulness in the tires industry.
I will continue the presentation with inventory analysis. Diagram 1 illustrated the process of producing tire from raw material including natural rubber, synthetic rubber, carbon black and chemical. The raw material are obtained from rubber tree due to their high elasticity and resistance to release. The output include carbon dioxide emission from deforestation and petrochemical process, waste from rubber process and carbon black production. The raw material are transported to the factory to process tire, which generated energy and emit CO2 gas. The manufacturing process include input like electricity, water and raw material, which release VOC, CO2, SO2, NOx, solid waste and wastewater. The transportation phase involve fuel input like diesel or petrol, release CO2 emission from fuel combustion. The usage phase involves tire installed on vehicle, releasing CO2 emission due to rolling, resistance and microplastic. The final disposal stage require energy for recycle and disposal process, which can be divided into landfill site or recycling material. Landfill site may result in higher pollutant due to tire regrading, while recycling material can be used to create new rubber product for automotive product like floor mat.
Next, we will discuss about life cycle impact assessment. Life cycle impact assessment of tire factory starting from raw material until the disposal that include input and output. Firstly, starting from raw material, tire use either natural rubber or synthetic rubber. Use natural rubber can require intensive land use because to plant many rubber trees. This can cause deforestation activities that can affect climate change and habitat flora and fauna loss. Next, synthetic rubber is used non-renewable material is petroleum. This can reduce non-renewable raw material resources. During manufacturing process of tire also can give many effects to human health and environment. Use heavy energy intensive during operation can produce harmful gases like carbon monoxide, sulfur dioxide and nitrogen dioxide. These harmful gases can cause greenhouse gases that can affect human health and harm environment. For example, humans can be exposed to heat stroke and phenomena of drought can occur. Other than that, chemical waste from tire factory also can cause water contaminant that can affect water bodies such as river and groundwater. During use phase of tire from consumer also can give effect. For example, noise pollution can affect human daily life and their health, especially people that live in the city. In addition, tire that has worn out will be released chemical known as microplastic. This can cause water pollution because the chemical release will be carried by surface runoff to enter the groundwater and can also cause the soil to become acid. Lastly, tire that has been used by consumer will be disposed to landfill. In landfill, tire take up a lot of space due to their large size and non-biodegradable properties. Besides that, leaking hazardous substance can absorb into the groundwater and soil, which can eventually lead to leachate. In addition, tire also can cause fire hazard that can burn for extended period of time and can producing hazardous gases and other airborne contaminants.
I I will continue the presentation with inventory analysis. Diagram 1 illustrated the process of producing tire from raw material including natural rubber, synthetic rubber, carbon black and chemical. The raw material are obtained from rubber tree due to their high elasticity and resistance to release. The output include carbon dioxide emission from deforestation and petrochemical process, waste from rubber process and carbon black production. The raw material are transported to the factory to process tire, which generated energy and emit CO2 gas. The manufacturing process include input like electricity, water, and raw material, which release VOC, CO2, SO2, NOx, solid waste, and wastewater. The transportation phase involve fuel input like diesel or petrol, release CO2 emission from fuel combustion. The usage phase involves tire installed on vehicle, releasing CO2 emission due to rolling, resistance and microplastic. The final disposal stage require energy for recycle and disposal process, which can be divided into landfill site or recycling material. Landfill site may result in higher pollutant due to tire regrading, while recycling material can be used to create new rubber product for automotive product like floor mat.
Life cycle interpretation is to identify the reliability and limitation of finding from LCA of tire factory. From the result, it was observed that in the gate-to-gate approach, the extensive use of energy such as electricity during the tire manufacturing process is a major contributor to the problem of environmental pollution. Tire production process has a major impact on the environment in terms of contribution to inorganic material, affect human health, global warming, and depletion of natural resources. Last but not least, the tire factory production process need to produce sustainable and green energy sources.
Assalamualaikum warahmatullahi wabarakatuh. My name is NOOR FAZNYSHA. My metric number is SITI917. So today I want to talk about improvement analysis. Improvement analysis that I categorize which has two types, which is my own opinion and based on article. So my own opinion have a 4 improvement analysis, which is redesign the product, change the material, improving process, and implementing rescaling measure. My first point is redesign the product. Feasibility for redesign the product, redesign the tire, increase fuel efficiency, durability, and riskability. For example, by creating the tire with lower rolling, it can minimize fuel consumption and greenhouse gases emission. For essential for redesign the product, which is R&D, it can be difficult to ensure the tire is safe or good performance for requirement. My second point for improvement analysis, which is change the material. Feasibility of change the material is use the sustainable material, natural rubber alternative. By recycle rubber can minimize the environment impact, and for the example, by reducing on fossil fuel and waste generation. For potential of change material have a limited availability and the quality is increased, price is up and down, and need to do testing and validation. My third point for improvement analysis for the tire factory is by improving the process. Feasibility of improving the process is use energy efficiency technique by the recycle and water reduction. It can help to reduce resources consumption and emission. For the potential improving process, which is appendix for the retooling and training, which is technically have a technical limit and need to follow the compliant. So T is based on article that I researched the internet, which is improving the fuel efficiency. 2. ELT recovery strategy. 2. ELT recovery strategy. 3. Additional fuel consumption. 4. Use energy integration. And 5. Use renewable and raw material. Conclusion for this report for tire factory is the study revival 50 paper on tire life cycle assessment (NCA) over the past decade, focusing on life stage, secondary material redesign, comparison, and new impact. Most research focus on the transport stage with carbon emission mainly from use to improve the environmental performance, recovery of ELT, and use of secondary material and innovative tire design are recommended. Inconsistencies exist in various elements and sensitivity urgently analysis can exceed LCA reality. That's all for me and thank you.